can I check for that?
in the thing that says academic on it. Okay, so we start off, I'll have these graded too, in fact, these quizzes graded back to you on Monday. We started off, actually I have a lot of stuff to turn back to you, with some inequalities. So let's just go ahead and see if we can follow through these problems. These are questions that are going to be on your test, you guys, so we need to know how to do these. I think you can. What are you going to do first with this guy?
Gotta get it on one side.
Gotta get on one side. You gotta have a 0. So we're going to subtract that 8x and get ourselves a 0. If you're doing an inequality by hand, now later on I see there's a calculator problem, but if I'm doing them by hand, then I need a 0. Okay? Then what? Factor out an x. Right? Then what? So I know, now there are two ways I can do this. I can do it with a number line, or I can do it with my coordinate plane. I know I have a 0 at 0, and I know I have a 0 at 8. And technically, those are open dots, agreed? Okay? Now, this is an x squared equation. It isn't a polynomial, it's not an x cubed. It's a plain old x squared equation. What do x squared equations look like? Parabolas. So this is some kind of a parabola that looks like this. And I want to know where it's bigger than 0, which is above the x-axis. So that would be this part of the curve and this part of the curve. Now, if I did it on the number line, which would be another option, you would have shaded over here and shaded over here. So what is my answer? What do I write down as the answer? Negative infinity to 0, and then 8 to positive infinity. If you're wondering about, like, okay, I hope that makes sense to you. It's a parabola. We know where it intersects those sort of zeros. If you're doing it with a number line, to figure out where to shade, you can pick a number, see if it works or not, and then alternate the shading. Remember that on the number line, if that's your choice. All right, let's look at B. Same kind of problem, but bigger. So what are we going to do first? Get a 0. And yeah, I would love to factor by grouping, but it isn't going to work. Because remember, you can factor these, but they have to give you the same parentheses, and you won't get it here. So we're going to need our PRRs, which are factors of 8. So 1, 2, 4, and 8, plus or minus. So pick one, I don't care. 2. I don't think 2 can work. Let's try negative 2. Will that work? Yeah, there we go. Remember, you just have to keep trying until you get one. But don't forget you can try negatives as well as the positives. Okay, if I were you, I would right now, I I would put a point at -2. Whether I'm using the number line or the coordinate axis, I would plot my -2. Because any number that gives you a 0 is a 0. So it goes on the line. Then what?
X squared plus
Look at
3x
what's
plus-
left, which is x squared plus 3x minus 4. And that's gonna factor x plus 4 minus 1. Which means I have 2 more zeros. One at -4 and one at 1. You with me? This is a cube. Cubes start down here. Do you remember that? That shape right there? Does that look okay? And this time, I want to be less than or equal to 0, which means these are closed dots. And less than means I'm under the x-axis. So that would be this part right here. And this part right here. So the answer is the x values. So what x values are those? Negative infinity to -4, and that's a closed dot, so we'll put a bracket on that one. And then what? -2 to 1. That's a test question. Did you follow all the steps? Now, if you happen to get one that factors by grouping, feel free to do that. Feel free to factor by grouping if yours does. But if it doesn't, you're gonna have to go through this. Okay? We all right? Okay, let's look at the next one. It was kind of a common theme. Now you get a 0. This one's a little bit different though, because when I subtract the 2, now I have a fraction minus 2. So I really have a fraction minus another fraction. And what do I always do? Since second grade, when I have a fraction minus a fraction, I get a common denominator. And my common denominator is that right there, x plus 4. So this one needs an x plus 4 on the top and the bottom, of course. So now instead of having 2 separate fractions, I can write it as 1 fraction. And the numerator will be x minus 3, be careful, minus 2x minus 8. Because I'm distributing here. So then I can clean up the numerator. And it will be negative x minus 11. Now, I don't really want to graph that. It's going to have asymptotes and everything. So I think I'm just going to use a number line for this one. You can graph it if you want, but I'm just going to use a number line. I know I'm going to have a dot at -4. I know that. That one is tricky. You want that, it isn't actually going to be 11. it's going to be negative 11. To figure out where to put the die, like this one I can eyeball, this one I can't, so I'm gonna set it equal to 0, and it's actually negative 11. Remember, the dots are the zeros. The dots are what makes it 0. So I can tell this one's negative 4, I can't figure that one out, so I solve it. Now, these dots should be filled in, but the denominator is never filled in, ever. So, that's gonna stay open, but this one's gonna close because of that right there. Now I gotta shade somewhere. How am I gonna figure this out? Plug in. I'm gonna plug in 0. 0 is the easiest number for me. 0's out here. So I am trying to figure out, am I gonna shade out here or not? So if I put in 0, I get negative 11 fourths. Is negative 11 fourths bigger than 0? Nope. So I'm not shading there. I am shading here. I'm not shading there.
I was thinking of when the times is like, when you do the opposite, but that's when there's like a negative, like, you know what I'm talking about?
Actually, okay, so actually that's happening here. Because normally, 2 dots greater than that is shaded out. But because of that negative, it's the opposite of that, and it's shaded in. So if you can remember that, you can definitely use that. It applies here.
Would you even have to figure it out if you like?
No,
were to
if
solve
you
it?
remember
Just
that,
like,
yeah.
have to do that.
Yep. So my answer is negative 11 to negative 4. We have all kinds of little shortcuts and things that we've discovered along the way. Use them, except never use them if you've got something like this. That messes up everything. So don't use any kind of shortcut if you've got a square in there. All right, that was C. Let's look at D. D is not an inequality. It's an equation. Do you see that? So we're not going to put it on a number line. We're not going to be shading. Our answer isn't going to look like an interval. Our answer is going to be x equals. So what do you want to do for this? I'm going to go ahead and factor my denominator. That last denominator can be factored. Dollars to donuts, it factors like this. Yeah. This one will catch you if you're not paying attention. This is actually a fraction also. So when you get your denominators to match, they all got to match. So this one is going to get an x minus 2. Tell me if you're not following what I'm doing. This one is going to need an x plus 1. This guy is going to need them both. And that guy needs nothing. You all right? So now I'm going to have an equation of my numerators. So I'm going to go ahead and FOIL that. So that's going to be x squared minus 2x plus 4. That's that one. plus, okay, I'll distribute this one, equals, oh, there's a lot here, so 4 times
Four x squared minus 9x plus.
don't just copy down what I'm doing, because Lord knows it could be.
Right, yeah, everything on both sides, 4x squared minus 9x plus.
What?
So I got 4x squared minus 9x plus 5.
Oh, when y'all clean
Yeah,
it
when
up?
y'all- yeah.
Alright, I'm not there yet.
Well, that's like squared, over 6.
I'm not gonna end up with an x squared. Okay, is that a mistake? I'm actually gonna end up with,
Do that first.
let me know if anybody else gets -3, and if not, then I need to figure out where I went wrong, which
I see that.
could be up here, definitely.
I thought you'd do just 4x plus 4x minus 8 for the,
No.
yeah, that's
No.
why I got it.
Yeah, so no, when you are multiplying 3 things together,
You gotta do one then by the other.
you multiply 2 together, and then take that answer times the third. That's not a distributed problem.
I got -3.
Perfect.
The brackets.
Okay, how are we? Are we catching up here? All right, I'm skipping E for a minute because it's with the calculator. We'll do that separately when we get to some calculator problems. So now I'm on number 2.
But you had the x minus 2 is 6 off.
I have factored everything. So the first thing I did up here is pull out the 3. Does that make sense?
Yeah.
And then I factored that guy, factored my bottom, and those are going to cancel, which means eventually my picture is going to have a hole in it. And this is what I am ultimately going to be graphing. Would you agree with that? So, all right, we have a whole bunch of stuff. What do you want? I gotta graph it and fill in all those blanks. So, what do I do?
Vertical asymptote is -2.
Vertical asymptote at x equals -2. Definitely go along with that. because vertical asymptotes come from our denominator of your simplified problem. Make sure you simplify it, and there you go. Perfect. What else? Jimmy?
I might be wrong, but because we crossed out the x minus 2,
Mhm.
that's a whole, right?
And where will that hole be?
At 2?
2 comma something. So in order to plot it, it's a point. In order to plot it, we need a y.
So plug it in.
Plug in 2. So plugging in 2 will give me 21 over 4, which is a little more than 5. So 2, 1, 2, 3, 4, 5. Did everyone follow that? Okay. What else? Then?
Horizontal asymptote at y equals 3.
Yep. Why is that? Does everybody realize why that is? Because we have 3x over x or 3x squared over x squared. Okay, what else? No. The x-intercept comes from the numerator.
Do you know which is what?
Okay, so the x-intercept is gonna be at -5.
Yeah.
And then to find the y-intercept, I'm gonna plug in 0. So that's gonna be 15 over 2, which is 1, 2, 3, 4, 5,
A little over 6.
6, 7, 7.5, 15 over 2.
Wait, 2, 4, 6, 8. Yeah, that's like 7.5.
Yeah. Alright, so you're gonna need to list all that stuff, or at least some of it, whatever the questions ask. Everybody good? Then you have to sketch it. So looking at what we have, and knowing what the shape is going to look like, can you see this kind of?
Yep.
And then, remember, you got this guy down here. So that. Your picture is always going to have this shape or this shape. Always. When there's one vertical asymptote. We okay with that? All right. Number 3, easy peasy. How do we find our end behavior asymptote?
Set 3 to the division.
Yep, it's either gonna be horizontal, which this one isn't, or I'm gonna have to divide. Did you get y equals 2x plus 2?
Yes, it is.
Remember, nothing over here matters, we don't care about any of that. This is x squared, so this is gonna be x. There we go, 2x plus 2. Now I wanna jump down to problem A in number 5. We've done these before, we're doing them again, and you'll do it on your exam. Do the Lauren is creating a box to hold the cross-country memorabilia. She has a piece of paper that's 24 by 30. the box must have a volume of at least 1,000. So the volume has to be greater than or equal to 1,000. Does that work for you? She's gonna cut congruent squares out of each corner. You know, we've done this a zillion times. Folding up the flaps to make a box. How big must the cutouts be, and what is the domain of the problem? Okay. Before we go to the calculator, let's come up with an equation.
30 minus 2x.
30 minus 2x,
24 minus 2.
24 minus 2x,
That's
and x. That is the volume, length, width, height. That has to be greater than or equal to
that.
1,000. So this is a little bit different. Usually you want to maximize it. Now we just want it to be greater than or equal to 1,000. Before I go to my calculator, what's my domain? X min, the smallest
Zero.
x can
Zero,
be
12.
is 0, and the biggest x can be is 12. Half the smallest dimension. Right? So when I graph this on my calculator, there is x min, there is x max. Remember, it's gotta be bigger than 1,000, so y max is gonna have to be something like 1,200 or something. All right, let's see if we can find those points of intersection. We're gonna type in 2 equations. One equation is gonna be all these parentheses. The other equation is gonna be 1,000. And remember, what you are looking for in this problem
Alright.
is not the top of the mountain. What you are looking for in this problem is where they cross. Where does the volume equal 1,000?
Oh, I just deleted it.
So, those 2 points are,
6.
1.89.
don't spoil my surprise.
Come on, RB.
Actually, I got 1.884, is that what you said?
Whatever
I got
whatever I
looping.
can do, right?
Sorry? Around.
I got 1.884.
There's another one now, gotta find them both.
Yes, ma'am. Second count trace, intersect, would be good. My point is moving slower than the last. 7.555. And it's asking for how big was the
So,
cut. We have to feel something in.
how big must the cutouts be to have a volume of at least 1,000? Isn't this the part of the picture we're interested in? Because there it's above 1,000. So your answer is 1.884 to 7.555. Any cutouts in that interval will give you a volume that is 1,000 or higher. Everybody okay with that? All right, Bob likes lemonade, Max likes lemonade, what will Bob want? Okay, what is going to be our setup?
22 or 18?
Amount times percent
Amount times percent.
plus amount times percent
Equals amount times percent.
Yep. Now, sometimes when I write these problems, I try to be tricky, so let's read it carefully. This problem is all about percent water. Would you agree with that?
Yes.
So, percent water is 0.27 and 0.15, and I don't know. This is different.
We usually give you 3.
How much did Bob contribute? 18 ounces, so 18 ounces and 0.27. How much did Max contribute? 28. So how much did I end up with?
That was 2.
46. Listen, if Bob had jumped in 18 and Max jumped in 28, don't I have 46 ounces? I just don't know what that percentage is, so I'll figure that out in a minute. So here we go, 18 times 0.27. And 28 times 0.15. I'm gonna add those together. 9.06 equals 46x. 0.196956. So the question was, what was the percentage? About 19.7%, did you say? Because this is gonna round off to 7 hours. This is interesting. Henry can complete an assignment in 6.5 hours. If Sean helps, they get it done in 4. How long would it take Sean alone? What's your setup for that one?
1 over 11
Mhm.
plus 1 over 11 equals 1 over 7.
Perfect. So we're gonna have 1 over 6.5. One over x. Because isn't the 4, they're timed together?
Yeah. So we had times.
So I don't know, I don't wanna mess around with this thing. I know that if I want those denominators to match, they all have to have a 6.5, an x, and a 4. So I'm gonna give them all a 6.5, an x, and a 4. So all the denominators will match if they all have a 6.5, a 4, and an x. So multiply. So 4x plus, what's 6.5 times 4? 26 equals 6.5x. I got Sean to be 10.4 hours. Somebody better check that.
What?
Okay, you guys are doing absolutely great. One more problem. Letter D. The math department wants to minimize the amount of poster board needed for the next math week announcements. We're committed to having 144 square inches of print material. So I'm gonna start drawing picture of this. square inches of print material, surrounded by a border of 1.4 on the left, 2 on the top, and 1.75 on the bottom and the right. Okay. Now I wanna find the minimum area. Alright, so first of all, read the question again and look at what I drew. Does that make sense to you? Do I know I know the area of the print material is 144,
Yes.
but do I know like the width of the print material? So I'm gonna call that X. That right there is X. Do I know the length of the print material? No. But I know that these two times each other make 144. So if that's X, doesn't this one have to be 144 divided by X? What happens when you multiply my blue times my green? Don't you get 144? That's what I wanted, so I'm gonna get this out of there for a second. So now, I need to know the area of the whole thing. So what would this be?
X
Well,
plus 3.15.
The blue part is X. But we added that and that to this dimension. What did you say that adds up to?
3.15.
So this whole thing is X plus 3.15?
Yeah.
Now, what about this whole thing? Well, it's 144 over X, but it got added 3.75? So would you agree that our area is X plus 3.15 times 144 over X plus 3.75? And we want to minimize that. So I'm not gonna mess with that. I'm gonna go straight to my calculator. I'm gonna type this in and find the minimum. That's what I'm gonna do. Alright, so. And if we don't get this done, you will have to work on it over the weekend. I should say you will get to work on it over the weekend. Okay, I got a hard time. I heard somebody say it's gonna be like a reciprocal function, and it absolutely is, because it has a denominator. Okay, I finally got something. Listen, solution of that problem, see if you can figure out what the dimensions would have to be for the minimum area.